Hi. So I want to talk about directing the director. Does everybody here know what I mean with director? So who's using Icinga for monitoring? Good, good, good. You're all bad. If you didn't raise your hand now, you're, well, start using Icinga or, well, do something else. Director is a tool for configuring Icinga. And we spent some time with Ansible for automating our Icinga configurations through Director. And I want to tell you about, well, how we did that and what we did else. So first about me, I'm with T-Systems. I've been working there for 15 years now. I think even a bit more nowadays. I have a role of systems architect, and well, my basic interests are stuff like monitoring, automation, a lot with databases and SQL, and also performance optimization and debugging typically shitty Java applications. But everybody needs a bad hobby, so that should be okay. So what can you expect from this talk? I want to show you a little bit of history, how our old monitoring looked, how we built our new monitoring with Icinga, then how we built it, how we implemented it. I'm taking the perspective of the user, and by that I don't mean end user, but the system administrator who is using the monitoring. And I want to show you some Ansible code. Why not? Because Ansible is cool. So where was our starting point? It was 3 years ago. We had one central monitoring solution, which was based on Nagios mainly, and had also some cacti in it for performance data visualization. And this one central monitoring system had also one central team who administered it. And this central team had to do all monitoring changes. You had to open a ticket if you wanted a new monitoring. The team would implement it and would commit, okay, we did it now, everything should be working. That's kind of cool because it kept the system stable and consistent in every regard, but it's also really slow and error prone. You have a problem spreading knowledge. You have a kind of not my problem mentality. So the service teams out there were like, well, yeah, the monitoring team has not implemented the monitoring correct. It's their fault. And the monitoring team was like, well, all these service guys, they don't know shit about monitoring, that they can't even specify some requirements. It's clear that this would be shit. So, well, it's clear who's responsible, yes? Even the other party. So we wanted a new system where we could implement self-service requests, and we wanted a system that is scalable and will work with many distributed teams. So basically what we wanted is monitoring as a service, and we wanted it for our projects, but we wanted also a system that we could sell to our customers. So 3 years ago we started a project for this. It's always really cool if you're an enterprise company with lots of employees, start some projects that will help you. And we started an internal project which tried to embed into every project we had in our house. So we're driving like, I think, 10,000 customer projects, and everybody wanted to have a say in it. So this took some time at the start. So after some long discussions, we pitched different tools against each other. We had tools like Zabbix, Prometheus, some other solutions, and also Icinga in the mix. In the end, we said, well, Icinga looks pretty great, as you can see, pretty great. It's fabulous. Why? It's great. It's great. You can even install it. It's the official skin. You know, yeah. So, well, yeah, so Icinga won the battle, basically. If you're interested in the story, I had a talk at OSMC 2017 where describing this more in detail, and where you can get a lot of the details with our development departments who had to chime in and all the other guys who wanted to say in this. So you can look this up if you want. but I tried to give you a short gist of it. In our first try, we looked at, well, we want to have Icinga, and we need to implement a central hosting solution for it. So let's build an architecture, because I'm an architect, that's what I do, and what I do typically well. So we had a starting point where we didn't even know if we could cover all requirements, but we started anyway. So we constructed a central system with basically 3 VMs, one database VM, one application VM where the Icinga stuff runs, and one satellite VM that should act as a kind of DMZ or proxy zone for isolating different projects and different customers from each another. So at first we planned with VMs and planned to handle tenancy stuff inside Icinga with stuff like namespaces or, well, basically config language. This didn't work really well because we discovered if we want to implement namespaces in Icinga, we will have to limit our users severely. We have to take away almost all features that are, well, the basic bonus of Icinga. So that's not what we wanted in the end. So instead, we took our time and did this. So now the central system is replicated. I'll try to show it here. For every single customer, there's a central monitoring system consisting of a master cluster, some time series database, a Grafana installation, and a web server, and one central MySQL cluster which handles all the data storage. And we built it in a way so we could replicate it 100 times if we wanted. And how did we do this? We used Docker and Kubernetes for it. It's a real nice use case for it, I think. It's better than running one app in kind of a scaling way and only having 20 containers in your Kubernetes. Now we have a Kubernetes installation which has, I think, 400 or 500 containers. That sounds more like the thing it was built for. While implementing this, we skipped almost all fancy features of Kubernetes because we wanted a stable system and not a fancy system. This turned out to be a good decision. So yeah, maybe more to this later. Yeah, and this is also a chart from my talk from earlier. At first, we were highly focused on implementing all config management in Puppet. And we also started to set up our Icinga system with Puppet. But when we did the switch to Docker and Kubernetes, we discovered Puppet and Docker don't really work well together. And we took the bite and changed all our config management scripts back to Bash, because Docker files are basically Bash scripts which produce an image, which is kind of working, but not really nice. So we were looking for a solution for this, for a better way of doing things. And back then, in 2017, we didn't have discovered this, but there's a way. There's a really good way, in fact. For Docker without Bash scripts, it's called Pecker and Ansible. So Pecker is a building utility typically used to build VM images or Docker images. And Pecker has also a plugin to execute Ansible scripts. And so we converted our installation scripts to Pecker and Ansible. And it's working really well so far. So I want to show you some code that you can get a handle on it. I hope this is readable. So basically, this is the old stuff that everybody should know from the Docker universe. We have a Docker file which has some actions in it. We also have a proxy because we are an enterprise company. Yeah, and here's happening some stuff. One shell script that does some installation stuff, and it does a lot of really nice things. So yeah, it does some group adds, some package installs, some change mod, directory creation, blah, blah, blah. A lot of stuff with no error checking, no real grouping in it in the end. Yeah, it's fine. Yeah? It's a fine new Docker DevOps universe. Everybody's going to want this. No, No, thank you. Everything working is not a quality criteria. Everything working is a get your shit done and leave criteria. So we changed this a bit. Let's see. Does it refresh? Yes. So basically with Pecker, we have a build definition that says we want to transfer some files, and then we have a provisioner running, which creates our internal repositories. We have still a shell script job to install Python and stuff, but then the main point is handled with the Ansible role. And this role is basically here. And you see, it's perfectly fine, readable Ansible playbook. A bit of a problem is you cannot use many roles for it because roles try to manage services and stuff you don't have in a Docker container at build time. So you still have to write the most of the stuff yourself, but with this good syntax and explanations with it, I don't think that's a really big problem, so it's just a detail in the end. And this works really well at scale. We're building our containers with this. And it feels great. Instead, with best scripts where you feel like I'm back in the 80s and trying to hammer something in my mainframe. Yeah. Okay. To get to my notes back. So, yeah, I already said we're running on Kubernetes. A lot of people think you're instantly in the cloud when you're running on Kubernetes. I say at first, don't ask me, I'm a happy user. We have a different team that runs Kubernetes. I trust them. Works really well so far. We just wanted to focus on building our monitoring system. And as far as I'm aware, our main Kubernetes cluster is running on premises, also managed with Ansible, built by the same team. And it runs really well. They update it regularly. We don't have problems with this. We also have one instance in AWS, but that doesn't concern us because the deployment works either way, so it works good. So now we basically have a pre-built software as a service monitoring system. We have a central team which keeps up with all updates. So Icinga updates, Kubernetes updates, everything is always on the latest or almost latest release if there are no big bugs. And we also had the positive part of this. We discovered bugs. And the big part is we discovered bugs that were not already known, which is kind of a nice feeling. I don't know, do you manage like enterprise Linux, RHEL, CentOS stuff? You always discover bugs, and then you look them up, and you see, oh, this bug is known since 2 years, 3 years, 5 years, maybe 10 years. But, well, you feel bad because you could have avoided this. But with Icinga, we had and with Kubernetes, we had the honor to discover new bugs, which is kind of, it's a better feeling. It's not really great, but you feel good because you discovered someone and had the chance to help some other people, so yeah. And we discovered that Icinga in itself is really good for self-service with a director. Everybody can configure everything they want the way they want. So works pretty well. And our central team is not only an infrastructure team, which, well, operates the monitoring, but they also take the responsibility on educating. They consult with the projects, optimize monitoring, they talk with the users, which is, most of the time, it's a good idea, if you have good users. They have a knowledge base, which is always kept on the current point. They offer a library of default checks and dashboards for Grafana. So they take the point in multiplying our knowledge and sharing what single projects created to the whole organization. And they're also helping with migrations from the old system. So yeah, basically, then the question arises, we've taken almost 3 years to implement this to the point we are now. Are we actually using this system? At first I have to say, the larger the company, the more time it takes to swap out its systems and introduce new systems. I think almost anybody can relate to this. We're currently running 29 monitoring instances. which supports 78 different projects in our company. That's about, I'd say, 1/3 to half of our operations projects we have at the moment. Yeah, but we have a lot of projects which just migrated the simple path, taking all their Nagios configuration, pumping it into Icinga and being done with it. So we have still a lot of people doing SNMP or NRP or even worse stuff maybe. But there's nothing worse really. Or it's really hard to get worse. Telnet-based monitoring. Yeah, so we try to push all new projects to use native Icinga implementations like Icinga Agent and do it the right way. That usually works with completely new projects. With projects that already have some existing monitoring, they usually want to take their existing scripts and paths. So it takes a bit longer than expected, but things are improving, and that's, I think, the most important point. So we also have some challenges with this. We are very decentralized. We're working in small teams that basically can decide on all details themselves. So we need a lot of synchronization. We need to talk a lot. We need to discuss individual solutions, implementations, and, well, share knowledge in a basic part. And we need to talk a lot, because when you have like 100 engineers implementing away stuff they think is right, and running in 10 different directions, you need to synchronize and you need to well, evaluate why they're running that way and not the other way, and maybe which way is better. So what can I say, what I've observed? Old habits die slowly, very slowly. There are still people who think SNMP is a great idea. Just a small laugh? I would expected you to fall over or something. No, NRP is the same, I think. Yeah. And we discovered also that self-service alone is really insufficient, because if you leave people alone, they just, well, they run away in despair, because they never had to bother thinking about monitoring. They never had to think about the details, the consequences of building stuff. So you also need enablement. You need someone to share knowledge from the central monitoring team, to share knowledge to the new users, but basically to enable them, to give them the chance to do something right and not fall on their feet, on their nose in the first point. And, well, Icinga Director with a web UI is a really good starting point, because it's relatively easy to use in the first point. So at the start, we had a lot of people clicking around in Director, assembling their monitoring, which was kind of good, because they did stuff themselves, which was what we wanted. But usually, our main target was more. We wanted to have an automated, mechanized solution for monitoring. So it took a bit of time, and then things happened. Users discovered that basically Icinga has a really good API. So I think you know this. You can take any URL and request it as JSON and get JSON back. This works for Icinga, this works for Director, and it's a real good design choice, I think, because it enables and eases automation in every way. So it took a few weeks, a few months, and we had users using this API with Python scripts, with Perl scripts, to siphon off data, create documentation, enhance documentation with it, make some reports on on-call duty, on phone calls, on emails, and just quantize them and see what servers are failing regularly and stuff like this. Yeah, and creating dashboards for themselves for, well, monitoring TVs we have in our offices and stuff like this. So basically what I'm saying, if you build it, they will come. If you give people possibilities and give them the freedom to use them, people will build good things with it. They need time, they need knowledge, but I think everybody has a drive to self-improve and to well, make the systems better they are using. So we had already used the Icinga API to create reports and stuff, and now the first people were coming with, hey, I'm using Ansible to install and manage my servers. why can't Ansible also, well, administer the director and add the necessary monitoring points to it? It's just the next logical way for it. So we kept looking into upstream and searched for Ansible modules to manage our monitoring configuration. We found some modules and some roles, but almost all roles only targeted the Icinga API without director. So they wanted to push configuration directly into Icinga. That is not really what we wanted, because this way you would shoot beside the director and didn't have a complete view of the configuration inside director anymore. And that's not really what we wanted. So we decided to roll our own. And since the JSON API in Icinga is pretty great, we could use the URI module, which can dispatch web requests via Ansible scripts. And well, this was our starting point, and we said, well, we start there, and maybe we improve on it and stuff. But let's see how it goes. So this is basically a part of our script. It's a good name. See if the service template already exists. What does this do? It makes an URI request with all our checks. And basically, it looks for director service and checks if the name is there. And then it registers if this name is present. So the next step is create the service if it does not exist. So basically, we say we're accessing the presence array, and if it's an error in this content, because it's not present, Icinga answers with an error service not present, we create it by simply passing a post to the director service with some body information. And that's it. Then the service is created. And we also had some script to update the service, to modify a service. The only thing that's different here is that you have to specify the service in the URL, and that's it. We also had some failure conditions we caught, basically when we changed stuff and when it failed. So this could also report if we had some changes inside the services, so we could see in our Ansible logs what exactly was modified with one Ansible run. Works quite nice. So we have implemented this for all relevant Icinga objects we have. So for hosts, for services, variables, mainly apply rules. That's our main usage criteria. And for templates. So that was basically the backend, where we are doing the configuration. And now the user part, if you want to use this. If you look into Icinga, an apply rule looks kind of like this. You have an apply service, which imports something, has an assign where, and has some variables to it. Looks easy, is easy. And that's the way how it looks in our Ansible configuration now. We have an object name, we say it's an apply rule, it has an import, assign filter, and has some variables. And that's enough. We have a YAML file with all these definitions in it. We have our Ansible director, or Icinga director role, which imports all these definitions via URI calls. And this works great, really great. So we have now a complete Icinga configuration inside Ansible, can push it anytime to the director, and we even can enable or disable auto-deployment with director, so we can say, push the changes to director. I want to have a manual review because they are great, because the changes are, there are a lot of changes, or I want to have some small change and I do an auto-deploy, so the change goes live immediately to the Icinga monitoring. Well, yeah, so we created a role for this, for usage with all our teams, and we shared it to our teams and discussed about it, consulted with our colleagues to explain to them how this works, had a lot of meetings because it needs a lot of explaining at first, and we discovered some problems. We had built the role in a kind of style that all the complex configuration is one single file. And what you end up with is one YAML file that's like 700, 900 lines long. That's really great because all is in one place. You know where to look. But it's not so great because all is in one place and you don't know where to look. So, and one team discovered we don't have a delete feature yet. So we can create new, we can update, but we cannot delete or could not delete. And one team said, well, I'm writing a lot of assign filter rules and I don't like this, it's redundant, maybe I have a better solution. So basically what happened is this. We showed them our config file. I don't know if you see it on this side, it's really long, 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 long. And the reaction was like, hell no, I want to go, not anymore. And what they basically wanted was a file that has kind of like this. It's slightly more than one monitor, and they searched for ways to do this. And they searched for ways while preserving our initial script, which is kind of nice because you are fighting always the not invented here syndrome of people doing stuff in you if it's not necessary. And we wanted to work together and, well, keep things functioning and on the same page in the end. So what they created, what's this? That's a structure that's roughly taken from Puppeteer, where you say you have some general configuration. I think the names already give away what's inside, so no real explanation necessary. And this is, in fact, the interesting part. They created a hierarchy where the apply rule is constructed from the folder names. So they would create it would auto-create for this file, it would auto-create apply rules for all hosts that have SRV in server name. For this all, it would create an apply rule for all hosts that have SRV and integration in their server name. And so our users could keep the configuration in the files really, really short, had a very granular way to applying rules by server name. That works really well for us, at least, because we name our servers like human readable and not some serial or ID number, which we think is kind of a benefit, especially if you can order it like this. So yeah. What has changed? Now we have a hierarchical host configuration. We have really short configuration files. The team did reuse our initial role, almost unchanged, just extended with a delete feature. And we have a delete feature now, which is really great because now we can really do anything inside Icinga from Ansible without much effort. Yeah. What's left to do? The module itself needs to get faster because we're doing a URI request for every single object inside Icinga. It takes some time at least. Icinga is really fast, Ansible is really fast, but creating 2,000 or 3,000 objects and checking them every time is not so fast, regardless what you do. So maybe we will look into stuff like config baskets and what's new in the new director. That should improve this substantially. We are thinking about going away from the basic URL module and writing a standalone Ansible module for this to get better error handling and some better config options for this, because it's like a bit of complicated if you want to debug stuff, so it's not really good. And we really want to push this upstream. Originally, I wanted to make some Big Bang release here with, well, now it's on GitHub, but, well, time flies if you're having projects, so I didn't come around to this. But I think in the next 2 or 3 weeks, I will get around to publishing this as open source for everybody to use. And it's really a road we want to go, because keeping this stuff inside your company is not good. Really not what you want. Wait, we did more. We did more. Not exactly with Director, but we also had some other realizations what we can do with all these API integrations in Ansible. So we wrote a small module to set downtimes in Icinga. So basically what we do, we say, here we can add a service downtime with a comment to it, with a duration, and with some services, which are now in downtime in Icinga. and we also can delete this downtime with an Ansible playbook task. Well, can you guess why this is really great? Because if you're doing deployments and backups and stuff with Ansible scripts, you can just turn off the monitoring. It will not bother you. You're fighting the notification fatigue because you're not generating notifications when you're doing regular stuff. And also the people using the system see, oh, this is in downtime. It has a comment from Ansible, so there's some script running with it. And I should not touch the service or should not interfere with it. Or maybe they're seeing, oh, it's running really long and the downtime timed out. Still the comment inside and I need to check my automation. And it's really great for the teams because, well, it gets some visibility into it. It eliminates tedious stuff like setting downtimes manually, like planning downtimes for monitoring, for deployments and stuff. And it's really good. So, yeah. So, speaking about notifications, we want all our production hosts and services to notify us on failure 24/7. That sounds like a good idea at first, but do you want to really have notifications for all services? I say no. It's like NTP or SSSD. If they fail, you usually don't have a problem. You don't have a problem you need to solve in the night. You can take some time for it. So you want notification rules with exceptions. And how do you define exceptions in Icinga? I've taken the screenshot from the director. So we say we want to assign our notification on all hosts within a host group live, and which are not in a service name some Oracle stuff that always breaks and should not notify. Looks pretty easy, right? It's like, it's from the book. It's like how you should configure exceptions. And that's the GUI way of doing stuff. So let's look at the Icinga configuration, Icinga text configuration. That's how it looks in text mode. Still pretty readable, still pretty logical, I'd say. So logical connection in it. And, well, now I need to transfer this to YAML and JSON syntax because I want to push it on an API to Icinga. And I end up with this. Yeah, good reaction, thank you. Well, that was easy, wasn't it? No, it's, of course, yeah, of course. That's easiest stuff ever. I would read this every time, all day. It's nothing better to do. So that's good, yeah, no, we just need to accept the reality in this. That will not work. That will not work at least for long. If you're the one writing this the first time, it will work. Then a colleague comes and changes it. And it might work, but differently. And then another colleague comes, changes it again, and it might work nevermore. So that's not a way you can configure this as a human. And I think exceptions to the notification rules or to other rules are something you create fairly regularly. That's not something you do one time and leave it alone for 2 years. That's something you do every week or every 2 weeks or so. And in this case, with notifications, it's extremely important. One single typo can mix up all of our notifications, break everything, make nothing notify, and it's really not what we want, really. So the basic only solution we found, while keeping to Ansible, this needs to be auto-generated in some way. And while we were with Ansible, we thought, well, design it from a user perspective. We take an input, which we called voice exempt in this case. And these are basically patterns that are matched. So I say every host with a host name DB or part of it DB and a service Oracle_soft is voice exempt. Every host name web with a service name HTTP hits in it is also exempt. So this is the way we wanted our users to specify their exceptions, because that's fairly straightforward, it's easy, it's not so error-prone. Yeah, and some way we needed to come from this to this. So we wrote, basically we were very excited that Ansible can do Ginger templates. And I had one night where I had some particularly good bottle of whiskey. And I wrote a task which transferred this array into the needed single string. Looks nice, right?
The whiskey was a blast.
The whiskey was really great. Yeah, yeah, it was really great. So in the output, in the end, it was like this. Just the basic Icinga syntax for it. Yeah, what is the result of this? We have an easy configuration via an YAML hash. We have an understandable array of exceptions. It's readable in the configuration. We have a not so good understandable rule for transforming this. Not so well, at least. But nobody ever needs to touch this rule. You never change this rule. It just runs in the background until it stops running. That's maybe a problem, but yeah, you're basically pasting it into your project at the right place. You're setting the input variables, you're setting the output variable, and use it. I'd say it's good enough for general use. So yeah, that's to sum up. What did we learn on our path? Always encourage sharing, because when people talk, good stuff happens. And when people don't talk, only, well, dark chambers with castles in it are created. Ansible in itself is awesome. And also trust your users. I myself was part of the first core monitoring team, and I had a really, really hard time to give up all these reviews I had implemented, because I myself felt responsible for making sure our monitoring was exact, was right, was in every way good. So main problem is people don't scale, at least not more than 24 hours a day. And I learned that I had to trust people, let them make mistakes. They will recover. They will learn much more from their own mistake than they will learn from chiding, from teaching, from, well, basically saying them this is wrong what you're doing. They should discover it themselves, what they're doing, why this is maybe wrong, maybe right, I don't know. Yeah, and that's it. So thank you for listening. And do you have any questions?